friends, myself Dr. Sumant G. Kadwane, and I shall be explaining you 8085 microprocessor programming lessons for beginners. But before understanding this video, you must first see my earlier video which explains the meaning of each of the instruction of 8085, which is provided in the link in the description. Outcome of this particular video is, after understanding this video, or after you see this particular video, you will be able to see the various 8085. You will be able to write various 8085 programs. So this particular video will be particularly useful for beginners. Now let us consider a program. We have to write a program to swap the contents of the two memory locations 2000H and 2001H. Now the contents are present in the memory. So first of all, what we have to do, that we have to transfer one of the number from memory to the accumulator. Thereafter we have to copy the contents of accumulator to some other register, let us say B. Thereafter we have to load the other number into the accumulator from the next memory location, and we have to store that particular number in the previous memory location, and ultimately we have to store the number which we have stored in register B in the first memory location. So this is how the contents of the memory locations 2000H and 2001H are swapped or interchanged. Let us see what is the program. So to move the contents of memory location 2000H into accumulator, you have to use the command LDA200H. To store the contents of accumulator into register B, we have to use the command move B, A. Once again, to move the contents of memory location 2001 into accumulator, you have to use the command LDA2001. Now we have to store the contents of the accumulator into the memory location 2000H. So we will use the instruction STA, which stands for store accumulator contents to 2000H. Thereafter we have to move the contents of register B into accumulator, and we have to store the contents of accumulator into the memory location 2001H. For that we use command STA2001H. So this is how we can swap the contents of the two memory locations, and this is the program where we have used another memory location or another register. We have taken the help of the third register in order to swap the contents of the memory location. So let us proceed to the next program. In this program we have to add 8-bit numbers which are stored at memory location 2000 and 2001 in 8085 microprocessor, and the sum is to be stored at 2002H memory location. So in this particular case we have to use one command add, and we can add the contents of memory to the contents of the accumulator, or we can directly add the contents of memory to some other we can transfer the contents of the memory to some other register, and thereafter we can load the contents of next memory location from the memory, and we can add it and we can store that particular. So it is very simple program. So let us follow the second method. First of all, we will load the contents of 2000H into the memory. For that, the command is LDA2000H. Thereafter, we'll store this particular uh, number into some register, let us say B. So for that we have to move or copy the contents from accumulator to B. For that command is mov B comma A. Thereafter we have to load the second number into accumulator. For that command is LDA2001H, and thereafter in order to add the contents of register B to accumulator we use the command add B. Now the result of the sum is stored in the accumulator, which we need to store at 2002H. So for that the command used is STA2002H, and thereafter we have to stop processing, that is we use the instruction halt. So this is very easy program, and next we will see how to add the numbers which can generate the carry. So if the sum of the numbers is within FFH, this particular program will work, but if the number exceeds FFH, in that particular case we have to store carry in some other memory location. So let us see how it works. In this program we have to add two 8-bit numbers which are stored at memory location 2000H and 2001H. But the problem here is that the sum of the addition may exceed FF, that is, it is insufficient to store in a single 8-bit memory location. So thereafter the carry will be generated, and we have to store the carry in the memory location 2003H. So let us understand what is the input data. The input data is located at 2000H and 2001H. We have to add them, and we have to store the sum in 2002H and 2003. So let us start working on the program. So in this particular program, we first thing we have to load the contents of the accumulator from the memory location 2000H. For this, the command is LDA2000H. Now thereafter we have to move the contents of the accumulator to register B. For that the command is move B comma A. Now we have stored the first number into the register B. In this program we are going to use register A to find out the sum, because there is a command add R which will add the contents of the R to the accumulator, and we have to find the sum, and register C will be using to find out the carry, and will store it in the 2003. So for that we have to once again load the second number, which is nothing but 2001, and we'll load it into accumulator. Now we have to add the contents of A and B. For the command is add B. Accumulator will store the contents of the addition, and if the carry is generated out of the addition, that is if the number exceeds FFH, in that particular case we have to carry out storing of the carry into the next into some memory location which is given as 2003. So what we'll do, that if there is a carry, we'll move to the label next. Next is basically the address, some other address at which we have written few commands. So if the carry is generated, in that particular case we have to increment the register C, or we have to store 01 into the register C, and we have to store the carry into the location 2003H. Okay, so before that the addition sum is stored into the accumulator. So what we'll do, we'll store the sum into location 2002H. For that the command is STA2002H. Now we have to move the contents of the carry to accumulator, and we have to store it into the location 2003. Why we are doing this? Because we are using the command to move the contents of accumulator to memory, that is STA, and in this way we will stop. But if there is no carry, in that particular case we have to store once again the contents of the addition into 2002, and we have to move 0 to the carry, and that is nothing but we will do it in case by zeroing this contents of C with the help of MVI C, 00 command, and we'll move the contents of carry to accumulator and will store it in 2003. So if there is a carry, the 2003 location will be stored as 1. If there is no carry, then in that particular case it will be stored as 0. So it is quite evident from this execution of the program or understanding of the program that some instructions are appearing to be redundant in this particular case, because we have not used any particular command which will directly store the contents of carry as well as the contents of the accumulator into the memory. So we'll see next how we are going to do that without using these redundant commands. Once again, we are going to see the program to add the two 8-bit numbers which are stored in memory location 2000H and 2001H in 8085 microprocessor. The sum is to be stored in 2002H and the carry is to be stored in 2003H. Now in this program we are going to load and add the two numbers in accumulator and move them to register L. Thereafter, whatever is carry we are going to store in register H, and we'll use the command shld, store HL direct into the given address. So what we'll do, first of all we'll load the first contents of 2000H into accumulator by using the LDA command. Thereafter we'll move the contents of accumulator to H and we'll to some other register, let us say H in this case. We'll load the second contents of memory location, like is next memory location contents into accumulator, and we'll add them with the value of H. Whatever is the sum, we'll move it to register L. Now the carry, if it is generated, it will be stored in the carry flag. So what we have to do, that we have to move the contents of the carry to some register, let us say H in this case. For that we'll use one logic, that will add the contents of carry to the accumulator, and we'll use the command ADC A. But before that we have to clear the accumulator. For that we have to use the command MVI A, 00H. What this command will do, it will clear the accumulator, and thereafter we will use ADC A. Now A is 0, it will be added to accumulator, so there is no difference in the contents of the accumulator. But if the carry is generated, then the carry will be added and the content of the accumulator will be incremented by 1. If carry is not generated, the contents of the accumulator won't be incremented and it will remain 0. Now we will move the contents of accumulator which contains the information about carry to register H, and will use the command shld 2002. This command will load the contents of the L into the memory location 2002. L contains the sum, and will load the contents of H into the next memory location, that is 2003, which contains the carry. And with this we can avoid those redundant instructions which we have used in the earlier slide. Next program is to find the smaller of two numbers which are stored in memory locations 3000H and 3001H. And we have to store the smallest number into 3002H memory location. In this case, what we have to do that we have to compare the two numbers, and one which is smaller we have to store it into the specified memory. So first thing that we have to do is we have to load the address of the first number in HL register pair, because HL register pair is the pointer to the memory. So we can use the command move a comma m to store the contents of memory to the accumulator. So we have to save the first number into accumulator by using this command. Thereafter we have to increment HL register pair in order to move to the next memory location. Then we will use the compare command to compare the two numbers. And if the carry is generated, then the smaller number is in accumulator and we have to store the smaller number to the memory location. But if no carry is generated, then the smaller number has to be moved to the accumulator, and thereafter we have to store that particular number into the given memory location, that is 3002H. Let us see the program. LXI comma 300. LXI means load, X stands for register pair, I stands for immediate address. So load immediate address 300H into register pair HL. Thereafter we have to move the contents of the memory location 3000H into A. For that command is move A comma M. Then we have to increment the pointer to the memory, that is INXH, that in turn will specify memory as 3001H. We have to compare the contents of the accumulator which contains the first number to the next memory location. And if the carry is generated, carry will be generated if the contents of the accumulator are less than the contents of the memory location. In that particular case, we have to directly store it to the specified memory location. But if it is not so, in that particular case we have to move the contents of M, which is a smaller number, into accumulator. So for that we use the command JC jump if carry next, and we'll use move A comma M if there is no carry, and we'll store the smallest number which is an accumulator to the specified memory location, and thereafter we'll stop. Write a program in assembly language of 8085 to subtract a number stored in memory location 2100H from the number in the location 2101, that is next consecutive memory location, using addition method. The result should be stored in location 2102H, and if the result is negative, the memory location should be loaded with 00H. So here there are two conditions, that if the result is positive, it has to be stored in 2102, and if the result is negative, in 2102 we have to store the number 00. Once again, in this problem the subtraction is to be carried out using addition method. That is nothing but using 2's complement. We need not use the command SUBR, right? So we have to do it using 2's complement, that is 1's complement, and then addition of 1 to the 1's complement, that is 2's complement, and thereafter we have to add it to the other number. Okay, so algorithm for writing the program is like this. First we have to load the contents which are stored in memory location 2100. Then we have to take the 1's complement, we have to add 1 to the 1's complement and get 2's complement which is stored in accumulator. We have to move the contents of accumulator to some register, let us say B. Load the contents of the next memory location 2101 into accumulator. Once again we have to add the 2's complement of the number which is stored in register B with accumulator, and if the addition of these two numbers is generating the negative sum, then we have to jump to some other memory location in order to process moving 00 to H and storing 00 from accumulator to 2102H. But if there is positive sum generated out of the earlier addition, in that case we have to move the answer to the accumulator and the answer is to be stored in 2102H, which is the specified memory location. Program is like this. We have to load the contents of the accumulator from memory location 2100H. Thereafter we have to use the command, that is CMA, in order to complement the contents of the accumulator, INR A in order to increment the accumulator. Thereafter we will store the 2's complement of first number into the register B. For that we have to use move B comma A. Thereafter we have to load the contents of the second memory location 2101 into accumulator, and thereafter we have to do the addition of B with respect to A. Now remember, A contains the 2's complement of a number which is stored in 2100. So this command is equivalent to B minus A. Now if the result of this operation is minus, in that particular case we have to jump to this particular location and we have to store 0 to accumulator and store 00 to the memory location 2102H. But if the result of this particular operation is a positive number, we have to store that positive number into the location 2102. For that the command is STA. So we'll halt processing in any of the result when the number is negative or the number is positive. If positive, it will be stored in 2102. If negative, 0 will be stored in 2102. So that is the. Now we have to write a program in assembly language using instructions to complement 256 bytes stored in memory locations starting from 2500H through 25FFH. We have to store the complemented data in the memory location which is starting from 2600H. In this program, we have to move a block of data from 2500H to memory location starting from 2600H, and the numbers that we want to move is 256 bytes, that is nothing but FF in hexadecimal numbers. So let us see what is the algorithm. First we will have to load the first number in HL register pair, because HL register is the pointer to the memory. Next, this 256 bytes, that is FFH, is to be stored in C register as an index register, or what we call it as a count. Thereafter we need to move the contents of the memory addressed by HL register to the accumulator, complement the contents of the accumulator and store 26H in H register, so that we can move the content of complemented data into the destination memory of 2600. Thereafter we need to store once again 25H in H register in order to move the data from the location starting from 2501. We need to increment the HL register pair and we need to decrement the contents of register C, which is our count, and we have to repeat the process in loop of moving the memory content from HL register pair to accumulator, and in this way we have to do it until the count becomes equal to 0. That is all 256 bytes will be transferred. Let us see the program. Now, first of all, we have to initialize HL register pair with 2500 contents. For that, the command is lxih, 2500h. Thereafter, we have to initialize the count. So, for that, the command is mvi c, ff. Now, c contains 256 bytes. We need to move the contents of the memory location 2500 to accumulator. For that, the command is move a, m. We need to complement the data, so CMA. Thereafter, we have to move the complemented data to the location 2600. For that, we will initialize only H with 26 so that the HL register pair contains 2600. For that, command is mvi move immediate data h, 26h. Now we need to store the contents of the accumulator into the memory location. So we'll move the contents of accumulator to memory with the command move m, a. Once again, we have to initialize h with 25 because what we'll be doing, that will be incrementing the HL register pair, and we need to decrement the count. So for that, the command is dcrc, and we have to repeat the entire steps of moving the memory content from 2500 to 2600 with incremented memory location. So we'll apply the command jump if not 0. This is the branching instruction. So this instruction will branch the address from the memory location, and thereafter we have to continue this particular loop until the count becomes equal to 0. And once all the complemented contents are transferred, we have to halt. Let us consider the example, what will be the value of accumulator and flags after the execution of the following program. Now in this case, we are given certain set of instructions and we have to find the solution. So first instruction is mvi d, 7fh. So 7f will be moved to the register D. Remember, 7 is nothing but 0, 1, 1, 1, and f is nothing but 1, 1, 1. So it will be the value of D contains 7f. Similarly, next instruction is mvi c, 3e. We want to move 3, that is nothing but 0, 1, 1, and E is nothing but 1, 1, 1, 0 into the register C. Now we have to copy the contents from C to accumulator. So now accumulator will contain whatever is the value of C. In this case it is 3E. Next instruction is RLC. What RLC instruction does? It rotates left bitwise without carry. Okay. So A contains this particular value. When we rotate it, in that case, when we rotate it bitwise left, in that case the most significant bit will be moved to carry as well as it will move to the least significant bit, and each bit will be shifted left. So after RLC, the accumulator will contain 0, 1, 1, 1, 1, 1, 0, 0, and carry flag will be 0. After second RLC instruction, this 0 will move here, and the instruction after this instruction, accumulator contents will be 1, 1, 1, 1, that is nothing but F, and 1, 0, 0, 0, that is nothing but 8, and carry flag will be 0. There is another instruction ANA, that is we want to AND the contents of accumulator with D. So this accumulator content will be AND with D, and thereafter after ANDing the result will be shown here. So in this way we have completed few of the programs, and you need to practice much more programs in order to get rid of the fear of writing the programs. Thank you for watching this particular video, and I will come up with the new series of programs. Thank you and bye for now.